Hello guys, today I'm going to talk to you about goal line technology and how electromagnetic induction is used in goal line technology. So before I explain goal line technology, you'll have to understand how in soccer a goal is determined. And so in soccer, a goal is determined. Let's imagine that this is the goal line, right? And whenever a shot is taken, a goal is allowed only when the ball completely passes the line, right? And if it partially crosses the line, that's not considered a goal. If it's very close to passing the line, but it hasn't, it's still not considered a goal. And so you can imagine how many problems or issues this causes, as in games, many shots, the referee is not able to determine if the ball crossed the line by millimeters or not, because they're humans and they're capable of errors, as we all are. And so in matches or in games, when a ball crosses the line but barely, and then the keeper grabs it, referee may not see it, may call it a goal, or other way around. And more importantly, in the 2010 World Cup game between England and Germany, very important game, the ball was shot by an England player. It hit the top post, bounced in the goal, and then bounced out, and wasn't counted as a goal, although it wasn't. So this brought a lot of controversy, and so FIFA started implementing goal line technologies. Now there's two goal line technologies. There's the Hawkeye system, which uses a bunch of cameras, and then there's Goal Ref, which uses electromagnetic induction. Now, before I explain or show you all this diagram, let me read you all the textbook definition of electromagnetic induction. It is the production of electric current across a conductor when exposed to a changing magnetic field, right? Is known as electromagnetic induction. Now, Michael Faraday, the guy who discovered electromagnetic induction, first, before using this experiment, he had already known that an electric current produces an electric field because of Mr. Hans Christian Ørsted's theory that an electric current produces an electric field. Now, keep that in the back of your mind as I explain this to y'all. But what Michael Faraday set up was, he set up a galvanometer which measures the electric current, right? And then he connected two wires to the coil, copper coil, and then he had a magnet, right? Because he thought if a current can produce a magnetic field, then can a magnet produce an electric current, right? So he wanted to test this using this experiment. So what he did initially was, imagine that this Sharpie is a magnet, right? And that the red side is the North Pole and the plain side is the South Pole. What he would do was he would first he held the magnet above the coil, and there was no reading on the galvanometer. It didn't react at all. So what he did was he placed the magnet into the coil, right? And there's a slight deflection in the reading. So imagine that this is the arrow, right, that measures the current. It goes like this. It goes like that. It goes back to zero. So what he did then was he took it back out, and it had the same measurement except in the opposite direction. So what he discovered was that the motion of the magnet causes the current causes the arrow to deflect, so the current, right? So what he discovered was the current is being induced in the opposite direction. So when it went in, it was going to the right, and when it went back out, it was going to the left, right? So it's in the opposite direction. So what he discovered was that the current is being induced due to relative motion between the magnet and the coil. Now, we already know about relative motion because we've talked about that in class this year. Now, Faraday, and he discovered that also because he did the same process with the magnet with the coil. For example, the magnet was held still and the coil was then slowly brought into the magnet, I guess, and then same reaction occurred, right? So what he concluded at the end of this is that the current is being induced. The current is being induced due to relative motion, right? That also the deflection reverses. The deflection reverses when the poles of the magnet, north and south, are reversed, and the direction of the deflection shows the flow of the current. So if the deflection was to the left, the current would go left. Deflection would go to the right, current would go right. And then also, the faster the magnet or the coil, the faster the motion of the magnet or the coil, the faster the deflection, would be, and so therefore you could conclude. He concluded, that the rate at which the current was being induced was also faster. Now, how does that tie into goal line technology? Well, let's imagine that. Let's imagine that this goal right here, right, is acting as the coil, right? Because it has a magnetic field generated, right? A low frequency magnetic field is generated around the goal, and it's monitored by plastic coated antennas placed in the post and crossbar, right? And then the ball acting as imagine like the ball is almost acting as the magnet is installed with is installed with copper coils inside between the outer layer of the ball and the inflatable inner layer of the ball, right? And so a passive electric circuit is installed, right? And so the way that electromagnetic induction works in soccer is that when a ball, let's say this is my ball, whatever, when the ball crosses the goal, a change in the magnetic field is measured through a software that the creators of GoalRef created. That once the ball crosses the imaginary goal line, let's say, in the system, that change in the magnetic field is detected. And so once that change is detected, it signifies that a goal is clear, or that a goal has occurred. So therefore, the system or the software alerts the referee through his watch that the shot was indeed a goal, and then it helps assist the referee that a goal occurred. Now, electromagnetic induction doesn't only help soccer, but it's encountered in our daily life, because when you drive over buried coils to activate a traffic light, when you're impatient, when you drive over it, it's because of electromagnetic induction. And then also when you walk through a security system, or when you scan the mag strip of a credit card, or when you're recording a tape in a tape recorder, electromagnetic induction helps or plays a role in our daily lives, right? And so thank y'all for watching. Hope y'all enjoy.